Today, I am going to discuss our fourth unit in applied physics. So, applied physics, fourth unit. What is the fourth unit? Dielectric and magnetic materials. So, applied physics, unit 4, dielectric and magnetic materials. Two topics are there, dielectric materials and magnetic materials. Yes, first part, dielectric materials, second part, magnetic materials. So first part, dielectric materials introduction. What is dielectric material? What is dielectric? Dielectrics are the insulating materials. You observe here dielectric. Dielectrics are insulators or insulating materials. Materials. So in insulator, there is no free electrons. For example, this is positive nucleus. The electrons are revolving around the positively charged nucleus, around the positively charged nucleus. So there is no free electrons. There is no free electrons means the electrons are strongly bounded to their positively charged nucleus. That's why there is no free electrons. There is no free electrons. If a material which is having free electrons, that is conductor. If there is no free electrons, that is insulator. That is insulator. So dielectrics are insulating materials. In dielectrics, all the electrons are tightly bounded to their positively charged nucleus, are tightly bounded to their parent molecule or parent nucleus, and there are no free charge carriers. There are no free electrons. Generally, the dielectric materials are non-metallic materials. These are having high specific resistance. High specific resistance. So these are having high specific resistance. What is specific resistance? You studied in your intermediate, resistance is equal to rho L by A. So rho is equal to RA by L. This is a specific resistance. Specific resistance. R resistance, A area, L length. Length. So dielectric materials are having high specific resistance. This is a very, very important property. So it has two multiple choice questions. Dielectrics are insulating materials. Dielectrics are dash. Conductors, semiconductors, insulators, all. So that is insulators. The dielectrics are having, the dielectric property is low specific resistance, zero specific resistance, high specific resistance, all. They will ask like this. So this is introduction. Introduction. You can see clearly here, dielectrics are insulating materials. You can see clearly what I am saying here. Dielectrics are insulating materials. In dielectrics, all the electrons are tightly bounded to their parent nucleus or molecules. There are no free charge carriers. These are having high specific resistance. So this is the introduction. Introduction. Electric dipole. You know very well magnetic dipole. Magnetic dipole. I am comparing. You studied in your intermediate magnetic materials. So I am comparing electric dipole with magnetic dipole. What is magnetic dipole? So for example, this is the bar magnet. So this is north pole. This is south pole. This is a center point O. From center point to north pole, small l. This is small l. L plus L. This is 2L. L plus L. This is 2L. magnetic dipole, this is north pole and south pole. The distance between north and south pole distance, that is 2L. Two equal magnitude and opposite poles are separated by a small distance is called magnetic dipole. Magnetic dipole. In similar way, I am taking at north pole minus q, minus q. At south pole, I am taking plus q. The distance between north and south, that is the same 2L. You observe here. So to equal minus q and plus q, magnitude of this minus q and plus q both are same. So I am writing here to equal in magnitude. Actually, they are opposite to each other. So opposite charges are separated by a small distance 2L. That is called electric dipole. Electric dipole. What is the definition? To equal in magnitude and opposite poles are separated by a small distance, that is called dipole. Again, I am giving the definition. So this is the definition. A system consisting of two equal in magnitude and opposite charges are separated by a small distance is called electric dipole. Dipole. So this is minus q, this is plus q. The distance between these two, that is 2L. Dipole moment. Dipole moment. So in your intermediate also, dipole moment, mu m is equal to pole strength m into 2L. This is the magnetic dipole moment. Magnetic moment or magnetic dipole moment. The product of pole strength and the distance between two poles are called magnetic dipole moment. You studied in your intermediate. But here, the product of this charge, magnitude of charge, and the distance between two charges in dielectrics or in dipoles, that is called dipole moment. Dipole moment. The product of magnitude of charge q and the distance between two charges, that is called dipole moment. It is represented by mu. Mu is equal to q into 2L. Q into 2L. So charge coulomb, distance meter. Coulomb meter unit. Unit coulomb meter. Every dipole has the dipole moment. Every magnet has magnetic moment. So every dipole have dipole moment. Permittivity. You know very well. This is permittivity. Epsilon is equal to epsilon naught epsilon r. In magnetic material, mu is equal to mu naught mu r. Permeability. So similarly, from this relation, epsilon is equal to the product of permittivity of free space and relative permittivity is called absolute permittivity epsilon. It is the property of dielectric medium. It indicates the easily polarized nature of the material. It is the property of dielectric medium. It indicates the easily polarized nature of the material. So, the polarized nature of the material is indicated by epsilon. That is equal to epsilon naught into epsilon r. Epsilon naught is the permittivity of free space, that standard value 8.85 into 10 to the power minus 12 per Newton per meter square Coulomb square. You don't by heart this unit. Just according to Coulomb's law, force 1 by 4 pi epsilon naught q1 q2 by that distance square. You know very well this formula. Just to mutual change epsilon naught and f. So epsilon naught is equal to 1 by 4 pi into f q1 q2 by distance square r square. So q1 coulomb, q2 coulomb, this is Coulomb square. Force, this is Newton, distance square meter square. So we can write this is per Newton per meter square Coulomb square. You just remember like this. So 8.85 into 10 to the power minus 12 per Newton per meter square Coulomb square. Epsilon r is the relative permittivity. It is also represented by K. It is dielectric constant. Dielectric constant. Epsilon r or K, that is dielectric constant, you can see here. So dielectric constant K or relative permittivity epsilon r. According to this formula, epsilon is equal to epsilon naught into epsilon r. Epsilon r is equal to epsilon by epsilon naught. That is also known as dielectric constant K. So definition, the ratio between absolute permittivity epsilon to the permittivity of free space is called relative permittivity or dielectric constant. Dielectric constant. The dielectric constant is dimensionless quantity. There is no units. There is no unit, dimension less quantity. No units, no dimensions. It is a measure of polarization in the dielectric material. Polarization, we should define dipole moment per unit volume is called polarization. That is polarization. So using the dielectric constant, we can calculate, we can evaluate, we can measure the polarization quantity, the polarization value, the polarization vector value. So it is a measure of polarization in the dielectric material. The dielectric characteristics of materials are determined by the dielectric constant or relative permittivity. Using the dielectric constant, we can characterize the dielectric materials. These are the dielectric materials or any conductors or any semiconductors. Using the dielectric constant, we can measure, we can characterize. So this is the dielectric constant. Electric polarization, it is also called dielectric polarization. Electric polarization or dielectric polarization or polarization in electrics. What is the definition of this? Is the syllabus, starting syllabus with electric polarization. This is fourth unit starting topic, dielectric polarization. So what is the definition of electric polarization? The process of producing electric dipoles which are oriented along the electric field direction, that is called electric polarization. For example, I am taking the dielectric material. So this is insulator. The dielectric material is placed in a electric field E. Electric field E. Then this is electric field direction. Then the positive charge move along the electric field direction and negative charge move away from the electric field direction. Move away. So this is the electric polarization. Electric polarization. The process of producing electric dipoles, this is a negative dipole, this is a negative charge, this is a positive charge, dipole. It produces some dipole. Electric dielectric material is placed in a electric field, then the positive charge move along the electric field direction, the negative charge move opposite of the electric field direction. In this process we get electric dipoles. This process is called electric polarization. Electric polarization, the process of producing electric dipoles which are oriented along the field direction is called electric polarization. That is the definition. So explanation. Positive, one second. Positive center of gravity. So this is negative center of gravity. What is the definition of positive center of gravity and negative center of gravity? And what is non-polar molecule? And what is polar molecule? You should remember. Right. So actually, every atom is electrically neutral. You know very well. Every atom is electrically neutral. Positive charge in the nucleus and equal charges of negative charge, that is electrons. So total neutral. Every atom is electrically neutral. Suppose we imagine, assume all the positive charges are concentrated at a point that is called positive center of gravity. If all the negative charges are coincide at a point, particular point, that is called negative center of gravity. What I am saying, just imagine, suppose we imagine, we assume all the positive charges of an atom concentrated to one point is called the positive center of gravity, and all the negative charges are concentrated another point, that is called negative center of gravity. You remember. What is non-polar molecule? If positive center of gravity coincide with negative center of gravity, this type of molecule is called non-polar molecule. Non-polar molecule. What I am saying, if the positive center of gravity or total positive charge is coincide with total negative charge, that is called non-polar molecule. What is polar molecule? This is the polar molecule. The total positive charge or positive center of gravity does not coincide with negative center of gravity. That is called polar molecule. Polar molecule. This is very, very, very important. You can observe here. The process of producing, you clearly observe definition, dielectric polarization. The process of producing electric dipoles which are oriented along the field direction is called electric polarization or polarization in dielectrics. So what is positive center of gravity? Up to here. What is negative center of gravity? So the total positive charge concentrated at one point, that is called positive center of gravity, or all the negative charges are concentrated at a particular point or another point, that is called negative center of gravity. So what is non-polar molecule? What is polar molecule? Already I discussed. In which molecule these two center of gravity coincide. Two center of gravity means positive center of gravity coincide with negative center of gravity. Then this type of molecule is called non-polar molecule. If the two center of gravity doesn't coincide, so this is coincide, positive center of gravity coincide with negative center of gravity. This is non-polar molecule. If the two center of gravity doesn't coincide with each other, this type of molecule is called polar molecule. Polar molecule. So explanation, electric polarization explanation. Let us consider an atom, dielectric material. So this is the non-polar dielectric material. It is placed in an electric field. So electric field E is applied on the dielectric material. The center of positive charge is displaced along the applied field direction. Assume this is the electric field direction. So positive charge move along the field direction and negative charge move opposite of the field direction. So this is the dipole. Dipole. So this process is called electric polarization. What I am saying, Let us consider an atom placed inside an electric field. The center of positive charge displaced along applied field direction, while the center of negative charge is displaced in the opposite direction. Thus, a dipole is produced. This is the dipole. The dipole is produced. When a dielectric material is placed inside an electric field, such dipoles are created in all the atoms inside. So the process of producing electric dipoles, are called electric polarization. So this is the electric polarization. What is polarizability? The polarizability is represented by alpha. Mu is the induced dipole moment. This induced dipole moment is directly proportional to applied electric field E. So mu is equal to some constant alpha into E. Alpha is equal to mu by E. What is alpha? Polarizability. What is the definition? The induced dipole moment mu per unit electric field. This is the electric field. Unit electric field is called polarizability. Explanation. So the electric field, the induced moment, dipole moment is proportional to the intensity of the electric field. So mu is directly proportional to E. So mu is equal to alpha into E. Alpha is equal to mu by E, where alpha is the constant proportionality is called polarizability. Alpha is the polarizability. Polarization vector. This is the polarization vector. So definition. What is polarization vector? Definition. You take here, this is P bar. Polarization vector is represented by P bar. So mu by V. What is mu? Dipole moment. So this is dipole moment per V is the volume. So dipole moment per unit volume, that is called polarization vector. One definition. You know very well mu is equal to Q into 2L, or induced charge Q dash into 2L. I am substituting as it is Q dash into 2L, all divided by. So you know very well volume, length into breadth into height. You know very well volume is equal to length into breadth into height. So length into breadth, we can take some area. So height also, it has some height. The distance between these 2 points, I am taking some length. That height, he is treated as some length. So I am taking that height has 2L. So substituting here L into 2L gets cancelled. Q dash by A. What is Q dash? Induced charge. Q dash, induced electric charge. A is the area. So induced charge per unit area of the dielectric material is also called polarization vector. So charge, unit, coulomb, area, meter square. So coulomb per meter square, unit.